Okay, the battery setup. Now, this depends on a lot of different factors. I mean, you've got to basically tie the charge controller and the battery system and the inverter together to the same voltage. And if you don't do it, basically you can't really go ahead with your solar system. So if you get a charge controller that's 24 volts, then you also need to get 24 volt battery pack and a 24 volt inverter. Or, you know, the other way around. If you've got a 24 or 36 volt inverter, you need to get 36 volt battery pack and therefore 36 volt charge controller. Anyway, so setup. So let's say we have these batteries. So we've got a car battery or something, and we've got the plus and the minus, and we've got another car battery there, and we've also got another plus and another minus. If we were to join the minuses together like this, and if we were to join the pluses together like this, what would we have? Well, we basically have another 12 volt battery, so it will be 12 volts, but the capacity will be doubled. So if these were 12 volt batteries and they were, say, 50 amp hour, then here we'd have a 12 volt 100 amp hour battery, and that's the way it works. Now, if you were to do it this way, where you have a, let's say, a car battery here, and we've got a car battery here, and we've got the plus and the minus and the plus and the minus. If we were to join them this way, so we get the minus here, and we join the plus to that minus, and we get the plus here, then what do we have? Well, if that's a 12 volt battery and it's 50 amp hour, we now have a 24 volt battery, still 50 amp hour. Oops, 50 amp hour. And that's how it works. And you can make this even more complicated and whatever by doing a series parallel. So this is called parallel, and this is called series. Now, yeah, like I just said, if you were to get this setup and combine it with this setup, that's called series parallel. And what it would mean is you get the best of both worlds, effectively. So you could double the voltage up and double the amperage up, but of course it costs more. Anyway, so yeah, that's kind of how you can set your batteries up. Now, it's kind of flexible, of course. You can join batteries up however you want, and you know, you've got to get it right, suited to your charge controller and suited to your inverter. So since we're talking about batteries, we also need to find out how to wire them properly. So we've talked about the setup slightly, but what we haven't talked about, which is very important, is the thickness of the cabling or the wires. So let's say we have different battery packs. Let's say we've got a 12 volt battery pack, we've got a 24 volt battery pack, and we've got a 48 volt battery pack. There's actually another common size battery pack, which I'm not going to deal with, and that's a 36 volt. Right, now, let's say we have a kettle, and the kettle is 1200 watts. Pretty low powered kettle, but okay. Now, if we were to work out how many amps we would have to draw from each of these battery packs, we would come up with this. So 1200 watts divided by 12 is 100 amps. That's going to need some pretty thick cable. So let's do the same for a 24 volt system. That would be 50 amps. A bit more reasonable. What about the 48 volt system? 25 amps, and that's easy. Now, the reason why this matters is because when you draw current through a wire, the wire can heat up because of resistance in the wire, and it can be a bit of a problem. So there's an easy way to deal with it. You just use thicker wires or thicker cables. So now, going back to this problem here, to do with the battery bank voltage, this is the issue. This here is a 4mm square cable, and this can deal with up to around about 40 amps. So in our situation here, where we have, you know, we want to draw 1200 watts from our 48 volt system, well, we draw 25 amps, which this can easily deal with it. It's very thin cable, fairly thin cable. It's cheap cable, thin cable, it can deal with it no problem. But going up to the 50 amp, well, this can't really deal with it. So if we were trying to draw 1200 watts with a 24 volt system, this would be dodgy. You couldn't really use it. The wires would get hot and you could potentially have some problems. So for that we'd have to move on to a thicker cable, and thicker cables are more expensive, of course. So we've got a thicker cable here. This is 10mm squared, which can deal with a lot more amperage. But look at this one here. So if we had a 12 volt system and we tried to draw 1200 watts or 100 amps, well, that's not going to deal with it. It's just simply not going to deal with it. So we have to go even further, and we have to use something that looks like this, even if this can deal with it. You know, so this is thicker cable again, and you know, the more thick we want to go, let's say we want to draw 2000 watts or something like that, well, we're going to need ridiculously sized cable. So we might end up with something like this, and not only is this expensive, it's hard to deal with. Look, you can't easily wire it. It's not easy to deal with. But this is 25mm squared cable, which is really thick, and it's designed for, off the top of my head, around about 200 amps or something like that. That's just off the top of my head. Now, there is more to it. There's a lot more to it. Distance also matters and all that, but I don't want to make this complicated. I want to try and keep it simple. So there you go. When you choose your battery system, you also need the proper charge controller for that voltage, and you also need the proper inverter for that too. So there you have it. Generally speaking, the higher the voltage, generally it's kind of easier, but yeah, there's a lot of factors. And the last thing I'm going to cover, or the last major component of a solar power system, is the inverter. So now we've got the power, we've got them from the panels, and they're in the batteries. Now, how do we get the power out? Well, with these panels, the panels give out DC voltage or direct current, whatever you want to say, and the wave is something like this. So if there's 0 volts, so there's say 24 volts or something like that. The wave will look like that. Well, actually, there's no wave. Direct current, there's no wave. The problem is that we use, or our mains is AC, you know, alternating current, and the wave looks more like this. The waves, I should say, look more like that. And basically, there's minus 300 volts, and there's plus 300 volts. This is like suited to the UK anyway. And the frequency of that is 50 Hertz in the UK. So this DC here is very, very different to the AC that we need. So to be able to actually use the power, we don't want DC, we want AC. So we need something called an inverter to create this this wave, if you like. So yeah, we need the inverter. And an inverter looks, it's usually something like this. It's usually a box, and you have some thick wires going to the input here, and you usually have some thin wires or a socket on the other side. So I'll just say socket. That's it, like a UK socket there. And this has a heat sink, heat sink, not heat shrink, heat sink over it like that to help keep it cool. And yeah, that's an inverter, and sometimes you have a remote on it or something to be able to, you know, monitor it and all this, that and the other. And yeah, that's an inverter. And the inverters have two things really which are important. They are the voltage. So if it's designed for a 12 volt system, a 24 volt system, 36 volt system, or 48 volt system. And they also have a maximum well, I can't say maximum, they have a wattage, so let's just keep it simple. They have a wattage. So you maybe, I don't know, 2000 watt inverter, which means that it's designed to allow you to draw 2000 watts continually. Sometimes they say, well, particularly with the Chinese ones, they'll say 2000 watts, peak, I don't know, 4000 watts. But personally, I'd avoid the peak thing and just go by the continuous. So you'll need an inverter, and the inverter, basically the thick wires connect directly to your battery bank, and then the socket here is effectively usable power. And they are the components of solar. So let's recap. So we have the panels, which you have to just choose the correct voltage, really, depending on your batteries. And of course you want panels that are big enough to power whatever you want to power. You have your charge controller, which basically charges the batteries so that you can drain the batteries later on. The charge controller is designed to look after your batteries as well as charge them. Then you have your batteries, which probably is going to be the most expensive part of your system, and they will probably be lead acid batteries. You'll probably need several, and you can wire them in series or parallel. Your batteries, the voltage of the batteries really determines the voltage of your charge controller and also your inverter. And then your inverter, that's how you finally get your power, which you can then use for whatever you want, like plug-in stuff, you know, or you can treat it as mains. And yeah, there are the basics of DIY solar off-grid power systems. Thank you for watching. Bye.